Hi folks, Astronomy Live here. If you were watching my channel earlier this morning, you might have noticed that I was doing a pre-dawn webcast of some satellite tracking, but instead of directly tracking the satellite, I was allowing it to streak through the view, catching up to it, and allowing it to streak through the view again. This is the Solar Dynamics Observatory, or SDO, and in less than a month, SDO will enter its next eclipse season. In preparation for that, I've collected these images in order to determine the orbit independent of NASA or any other government body by measuring its coordinates over time. By allowing the spacecraft to streak through the view, it makes it easier to astrometrically measure its coordinates because the stars are all nice round points in the image, which makes it easier for the astrometry software to solve the image. We can then measure the ends of the streak, which we know correspond to the beginning and end of each exposure, in order to determine the coordinates at specific points in time. In 2017, I used a similar process to determine the orbit of SDO and make a prediction about the eclipse season occurring then. But now it's 2019, and I have an automated bot channel called Annotated SDO, which automatically uploads predictions about every single eclipse that the SDO spacecraft will see, whether it's caused by the Earth or the Moon. Even so, some channels still persist in claiming that these events are unusual and not caused by SDO passing into Earth's shadow. In order to address this, I'm going to predict the entirety of the next eclipse season using nothing but my own observations collected with my telescope earlier this morning. I still had the orbital elements that I computed for the spacecraft from my observations of it back in 2017, so I used that as a starting point and fit those orbital elements to the observations I made this morning. The result was a very good fit to the data and a very good orbital solution. You can see the timing of each observation, as well as the azimuth and elevation coordinates, the cross-track error, and the difference in timing given by delta t from the predicted position and timing given by the orbit at the bottom. The last two lines of this screenshot are the orbital elements in standard TLE format. This format is used by a wide variety of programs to calculate where a spacecraft is at a given point in time, including by my software that runs on the Annotated SDO bot. Normally, this bot automatically downloads and runs off of the official orbital elements of the spacecraft, but in this case I've told it to run off of these orbital elements that I've calculated instead. Here's the resulting prediction video generated by the bot using my orbital data. The green line represents the edge of Earth's atmosphere, which will block the extreme UV wavelengths that SDO observes in with many of its CCDs. The purple line represents the physical edge of Earth's surface, but by the time that starts crossing the Sun, much of it will already be blocked by the opaque atmosphere, which blocks out many of the shorter wavelengths that SDO observes in. Up at the top left, you can see the date and time in universal time. This is the first eclipse of the coming eclipse season, and as you can see, it's predicted to occur on February 6th. An eclipse will occur each day thereafter throughout the rest of February and continue into the beginning of March. Now, even though the orbital solution I was able to calculate was quite good, it is still just based off of a single night's worth of data, and really less than an hour's worth of data at that. So it will become less accurate as time goes on, but in general it will give you the conditions for each eclipse throughout the eclipse season and the time to within a few minutes. Now, it's worth noting that the channels claiming that this phenomenon is unusual never manage to predict it before it occurs. And if you look at the dates that the eclipse season occurs from year to year, it's obvious why. If you don't understand the underlying mechanism, it's not really possible to predict it with any degree of accuracy. Here's a screenshot taken from one of those channels showing the start of the eclipse season changing from year to year. In fact, the degree to which it's changing is also varying over time. So that means it's so random that you really can't predict with absolute certainty what date the next eclipse season will start. It could vary plus or minus a day at least. That's why these channels aren't making definite predictions about the date where the next eclipse season will start. You can only do that if you really understand the underlying mechanism, which is actually the spacecraft passing into Earth's shadow due to its orbit. That orbit is also changing over time, in part due to thruster firings, whenever they do a momentum dump on the spacecraft, as well as the precession of the nodes of the orbit due to torquing from Earth's bulge and the gravitational field, and other factors as well. So it's really necessary to gather empirical data on where the spacecraft is and what its orbit is in order to make an accurate prediction, and that's exactly what I've done here. Let me be brutally honest here. I'm staking my channel's entire reputation on this. If I'm wrong and the eclipse occurs on a different date than what I'm predicting, that's it. I'm done. And they can take that to the bank. But the fact of the matter is that I will turn out to be correct here, because I do understand the underlying mechanism. Not only am I predicting when it will occur, I'm even showing a diagram of what it will look like as it's occurring. And on that note, this is something else they also tend to get wrong. Here's an image of a double eclipse caught by SDO. The moon is on the left, and Earth's atmosphere is at the top of the image. But a common objection I hear to this being caused by the Earth's atmosphere at the top is the jagged appearance it seems to have. At the focal length of the SDO imagers, you would expect Earth's atmosphere to look pretty flat, but it seems to be curved and jagged in this image. What is being missed here is the fact that the pictures and videos presented on the SDO website are extremely contrast-enhanced images that were processed from higher bit depth raw FITS files. You can download those raw FITS files yourself and process them as I've done here, and when doing that without clipping the bottom of the histogram, you can actually see a greater extent of the solar corona, and you can see that the horizon of the Earth is as flat as it should look given the focal length of the SDO imagers. The dimmer portions of the Sun, especially the portions partially obscured by the Earth's atmosphere, tend to be lost in the highly contrast-enhanced versions available on the website. But when you download the raw FITS files and process for the dimmer portions of the histogram, you can actually see that the images look exactly as you would expect, given the focal length of the imager and the expected position and appearance of the Earth's atmosphere. Again, these are extreme UV wavelengths that our atmosphere protects us against, and so it's extremely opaque to these wavelengths, even up to altitudes as high as 200 kilometers. You have to account for that, and you have to process the raw FITS files before you can make any judgments about whether this is truly the Earth's atmosphere or not. Once again, this video is a reminder that the SDO eclipse season is approaching, and the first eclipse of the season will occur on February 6th, even according to orbital data I generated myself from my own observations of the spacecraft this morning. You'll find a link to the Annotated SDO channel in the video description, and there you will find in the predictions playlist predictions for every eclipse of the upcoming eclipse season. The eclipse video predictions generated off of the orbital determination I made this morning are titled as Astro's Orbital Data Predicts. The older eclipse video predictions were generated off of the official orbital data, and if you look at those, you can see how well they agree with my own orbital data generated this morning. As always, thanks for watching, and clear skies, folks.